morning children. Today we are going to see a new topic. The topic of the lesson is periodic classification 1. First let me move to the introduction part. All the existing matter in our surroundings are made up of small units called elements, right? In 1800, only 31 elements were discovered. But after the advancement in science and technology, this number has raised to, that is in 1865, there were nearly 63 more elements were discovered. Presently, there are 118 elements known to us. Out of these 118 elements, some elements are man-made. Okay. And when there was only 31 elements, it was somewhat easy for us to study the properties of each and every element individually. But when this number has raised to 118, it is difficult to study all the elements, each and every element individually, right? So, scientists started to thinking about the various methods so that it can be easy for them to arrange the elements, okay, in a simplified method. So scientists they organize the elements. They organize the different elements in the periodic table based on their common characteristics, features, right? Next we can move to elements. What do you know about element? An element is made of one kind of atoms. Element is the building blocks of matter, right? Yes. So an element is a pure substance that is made from a single type of atom. Okay. What do you mean by element? Element is a pure substance that is made from a single type of atom, and elements are the building blocks of matter. Element is made of atoms only with the same atomic number. There are many elements, for example, iron, copper, silver, gold, hydrogen, oxygen, nitrogen, sulfur. These are some of the elements, right? Some of the elements that we use in our everyday life are calcium, magnesium, sodium, potassium, carbon, phosphorus, hydrogen, oxygen, etc. Right? Okay, so what do you mean by element? An element is a pure substance, right? It is made of only one kind of atom, right? Okay, next we can move to Robert Boyle assumption about elements. Okay, Robert Boyle was a famous English physicist, chemist and philosopher. According to Robert Boyle, an element is a substance that cannot be decomposed into simpler substances during chemical reaction. Okay, so Robert Boyle defined an element is any substance that cannot be decomposed into further simpler substances, okay, by physical or chemical change, or otherwise we can say during chemical reaction. Okay, so Robert Boyle hydrogen. Okay, how many elements are present in the periodic table? 118 elements. According to Proust, all the elements are made of hydrogen. Okay, Proust gave the relationship between the atomic weight of an element based on their characteristic nature. Okay, so atomic weight of heat, take atomic weight of element is equal to N. He noted the atomic weight of element is equal to N. Then what is N? What it mentions? N is equal to number of hydrogen atom. According to Proust, all the elements are made of hydrogen, whereas atomic weight of element is equal to N, right? He proposed atomic weight of element is equal to N, where N is the number of hydrogen atom, whether it is 1 or 2 or 3, like that. Okay. So what is the atomic mass of hydrogen? It is 1. At the same time, there are some drawbacks, that is limitations in Proust's hypothesis. What is the drawback? First one, every element which is present in the periodic table cannot be formed by hydrogen. That is the first drawback. Okay. So all the elements cannot be formed by hydrogen. Next, the atomic weight of all the elements were not found as whole numbers. Okay. The atomic weight of all the elements were not found as whole numbers. For example, if you take the chlorine element, its atomic weight is 35.45. At the same time, if you take strontium element, its atomic weight is 87.5. It is not a whole number, isn't it? So, these are the drawbacks, that is limitation of Proust's hypothesis, right? So, Proust's hypothesis says all the elements are made of hydrogen, whereas atomic weight of element is equal to N, where N is the number of hydrogen atoms. Okay, and drawback of Proust's hypothesis is every element cannot be formed by hydrogen. The next one, the atomic weight of all the elements were not found as whole number. Example, chlorine, strontium, right? Good. Next we can move to Reynolds Law of Triads. Okay, that's Reynolds Law of Triads. Reynolds was a famous German chemist. Okay, in 1800 he gave a relationship between the atomic weight of an element based on their properties. Okay. Also he noted that there are groups which are formed by 3 elements based on their similarities in their physical and chemical properties, and all the 3 elements are similar in their physical properties as well as in the chemical properties. Okay. According to Reynolds, in every group, the atomic weight of the middle element was half of the sum of the atomic weight of the remaining 2 elements, right? So these are called the law of triads. Okay, so these are the law of triads. It is nothing but group of 3 elements. For example, we can take the sodium element. What is the atomic weight of sodium? It is 23. For lithium, atomic weight is 7. And for potassium, atomic weight is 39. So here we have to use the formula, that is atomic weight of sodium is equal to atomic weight of lithium plus atomic weight of potassium by 2. We are taking average, arithmetic mean, isn't it? So you will be getting one answer, isn't it? So see, 7 is lithium atomic weight and for potassium atomic weight is 39. If you add these 2 atomic weight and divide by 2, you will be getting the answer 23, right? See, 23 is sodium element atomic weight. So Reynolds said in every group, okay, the middle element, the atomic weight of the middle element was half of the sum of the atomic weight of remaining two elements. Okay. Second, we can see one more example. Bromine atomic weight is 80, chlorine atomic weight is 35.5, iodine atomic weight is 127. So 35.5 plus 127 divided by 2. These two elements divided by 2, you will be getting 81.25. What is the atomic weight of bromine? That is 80. So nearer value, right? Next one, this is selenium. Selenium atomic weight is 78. Sulfur atomic weight is 32. And tellurium atomic weight is 128. So atomic weight of sulfur plus atomic weight of tellurium divided by 2, you will be getting the answer 80. And the selenium atomic weight is 78. So nearby value. Next one. Strontium atomic weight is 87.5. Whereas calcium atomic weight is 40. Barium atomic weight is 137. So atomic weight of calcium plus atomic weight of barium divided by 2. The answer is 88.5 and strontium atomic weight is 87.5. So this is called the law of triads. Okay. This law is called the Dobrenius law of triads. But after that, it was this law was not useful because it had some discrepancies. Okay, all the elements value are not true for each and every element. Atomic weight value is not true for each and every element. So this law was not successful. Okay. This law is called the Dobrenius law of triads. Got it? And there are some limitations in Dobrenius law of triads. What is that? The first one is all the known elements at a time could not be arranged in the form of triads. Okay. All the known elements at a time could not be arranged in the form of triads like this. So this is one of the limitations. Another one is this law is not helpful for very low mass elements as well as for very high mass elements. So these two are the limitations of Dobrenius law of triads. Okay, the first one is all the known elements could not be arranged in the form of triads. Next one, failed for very low mass element as well as for high mass, very high mass elements. These are the limitations of Dobrenius law of triads. Got it, children? Right. After the failure of Dobrenius law of triads, the English scientist and chemist Newland Optic, he gave the law of octaves. Okay. According to Newland, elements are arranged in the increasing order of their atomic weights. He started the element with the lowest atomic weight. Which element? Hydrogen. Hydrogen is having the lowest atomic weight 1. So Newland started the lowest atomic weight of the element hydrogen and ended with thorium element. Okay. He said that every eighth element of a row had similar properties to that of the same element in the first row. Okay. He proposed that, he said that every eighth element of a row had similar properties, same properties with that of the first element of the same row. Depicted the octaves music. Therefore, he called it as law of octaves. Also, it is known as Newland's law of octaves. Okay. So, Newland's law of octaves says if the elements are arranged in the increasing order, or otherwise if the elements are arranged in order, He studied the physical properties, different physical properties of the elements in the periodic table. First, he plotted a curve between atomic weight and atomic volume of different elements. Second thing, he arranged the most electropositive elements. Electropositive elements means elements which tend to lose electrons and form positive ions. These are called electropositive elements. So, most electropositive elements, we can call it as alkali metals. In the coming classes, we will learn about what is meant by alkali metals, what are called transition metals, what are the alkaline earth metals, everything we will see, right? So, most electropositive elements, that is alkali metals. What are the electropositive elements? Lithium, Li is lithium, Na is sodium, K is potassium, Rb is rubidium, Cs is cesium. So, lithium, sodium, potassium, rubidium, cesium, these are the most electropositive elements. Okay. These elements occupy the peak position on the curve. He plotted a curve in that all the electropositive elements occupy the peak position of the curve. That is the first one. Second one, less electronegative elements. Less electronegative elements, it is otherwise called alkaline earth metals. Both alkaline metals and alkaline earth metals both are highly reactive in nature, right? So, what are the alkali earth metals? Beryllium, Be, magnesium, Mg, calcium, Ca, strontium, Sr, Ba is barium. Beryllium, magnesium, calcium, strontium, barium, these are the less electronegative elements. Less electronegative means it easily attracts the shared pair of electrons. These elements attract the shared pair of electrons. That is called the electronegative elements. These less electronegative elements occupy the descending position on the curve. Okay, descending position on the curve, descending order. So, first, most electropositive elements occupy the peak position on the curve, whereas less electronegative elements occupy the descending position on the curve. Next, metalloids. What do you mean by metalloids? Metalloids means elements which can exhibit both the metallic character as well as non-metallic character, that is intermediate between the two. Those elements having metallic character as well as non-metallic character, these are called the metalloids. For example, boron, silicon, germanium, arsenic are some of the metalloids. These elements possess metallic character as well as non-metallic character, right? So, metalloids, boron, silicon, arsenic, tellurium, and transition metals. Transition metals means electrons filled partially, not completely. Okay, that is called transition metals. Metalloids and transition metals occupy the bottom position of the curve, right? Next one, most electronegative, that is halogens. Halogens means these elements will not react with other elements, that is called halogens. For example, fluorine, chlorine, bromine, iodine, these occupy the ascending position of the curve, right? So, Lothar Meyer, he was a German physicist. He plotted a curve and he studied about the physical properties of the elements in the periodic table. He plotted a curve between atomic weight and atomic volume of different elements. Most electropositive elements occupied in the peak position on the curve, whereas less electronegative elements occupy the descending position on the curve, and the metalloids occupy the bottom position of the curve, whereas most electronegative elements, that is halogens, occupy the ascending position of the curve. So, what Lothar Meyer concluded from this curve? From this curve, Lothar Meyer concluded that are the periodic functions of their atomic weights. So this only based on this conclusion he plotted a curve, right? Okay. So what are the things we have learned today? One is about the introduction part about the periodic table. Second one, element, and Robert Boyle's assumption about elements, and Proust's hypothesis is limitation of Proust's hypothesis, followed by Dobrenius law of triads, right? And limitations also we saw in the Dobrenius law of triads. It was not successful due to some discrepancies in that method. Next we discussed about Newland's law of octaves. Okay. And limitations in the Newland's law of octaves are all the elements could not be occupied in the same. On this basis, we cannot occupy all the elements. So that is one of the limitation of Newland's law of octaves. And then we learned about Lothar-Meyer's curve. Lothar-Meyer's curve concluded that from that curve he concluded all the elements in the periodic table or the periodic functions of their atomic weight. It resembles the Mendeleev's periodic table. Okay children, you will get the assignment today. Complete the assignment. The remaining things we will see in the next video. Thank you children.